Hi everyone, myself Bidyulata Sahoo, working as an assistant professor in the Department of CAC, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. This is my 21st video lecture on the course Applied Artificial Intelligence. Today I am going to discuss about the topic bounded look-ahead strategy and use of evaluation functions. These are the topics to be discussed. First one is the bounded look-ahead strategy and second one is the use of evaluation functions. Here is the topic learning outcome. After the completion of this topic, students can demonstrate a bounded look-ahead strategy with an evaluation function in a game-playing or problem-solving scenario to estimate the desirability of a game state. Let me give the brief introduction about this bounded look-ahead strategy. The bounded look-ahead strategy in the game-playing, it is a decision-making approach where the agent looks ahead a limited number of moves in the game tree to evaluate possible future states. The meaning of this bounded look-ahead strategy is like it is not very common actually. Why this topic we are studying in today's class? Because as we know, we have to search the search space. So search space, if it is feasible, then the searching will be very easy. Means if the path cost is less, it would be easy for us to do the search. But sometimes, especially in the game tree, as I have already discussed in my previous video, like the adversarial search techniques are used. Exhaustive search techniques are not feasible for game playing approach. Why the heuristic search or the exhaustive search are not advisable to do the search in game playing? Because in every game, if we start searching at every step, the game space will be explored to a number of further steps. So it would be computationally very much infeasible to find out. So that is why, to overcome that problem, this bounded look-ahead strategy is implemented in game playing algorithm. So it is a decision-making approach. First of all, we can find out a conclusion or we can do the decision at a particular depth. So where the agent looks ahead a limited number of moves. Looks ahead means, as if we consider the game of chess, the complete search space cannot be explored at a single time. So up to certain depth we can explore. Like suppose first move is done by one person, another move by the opponent party, and the third move would be by the same ourselves. So up to second move or up to third move, it is possible to search the game, or we can find out what would be the approximate cost is required to find out the goal state. So that is why it looks ahead a limited number of moves in the game tree to evaluate the possible future states. So here what happens, a particular depth will be considered. Basically, this bounded look-ahead strategy is used to limit the depth up to certain level so that the search space can be explored and the decision can be made efficiently within a reasonable amount of time. That is why this bounded look-ahead strategy is used in game-playing approach. So since look ahead indefinitely is computationally infeasible, as I said, complete search space we cannot predict, or it will be not visible for both the players to search this game tree, search space at the beginning time. So that is why we have to fix certain depth up to second depth or up to third depth so that the computation or the searching will be feasible, which is computationally efficient. So the search is bounded by a predefined depth limit. Here the depth limit, we have to take the depth limit can be 2, or the depth limit can be 3, or depth limit can be 4. We can take. So this strategy is commonly used in AI based game playing system like the chess game or Go game or other board game. If you consider the chess game, we can consider we can fix the depth limit up to 2 or 3, so that because at every step, in each step, what happens, the number of moves should be uncertain, like the number of moves would be more, which are called as the branching factor in our normal search space. So if the number of branching factors are more, then it is very difficult to search or to find out the goal state from that particular position. So that is why, to avoid that problem, this bounded look ahead strategy is used. Then let me discuss how this bounded look ahead strategy works. These are the 3 steps here. So the first step is expand the game tree up to a fixed depth. Suppose our depth is 10, we can fix up to second depth, because the depth which is visible to us, or the depth which we can predict, up to that depth we have to expand the game tree. Then evaluate the leaf nodes using the heuristic function. So here heuristic function is nothing but the in advance knowledge which can estimate the strength of desired position. That can be used for the terminal states, or the leaf node may not be reached within a depth limit. So back propagate the values using the strategy like minimax or alpha beta pruning to decide the best move. Anyways, these are the algorithms which are used in game playing. In my next video or next class, I will explain this minimax and alpha beta pruning. So that is why first we have to expand the game tree up to a fixed depth, and we will evaluate all the terminal nodes or the leaf nodes using this heuristic evaluation function. What would be the strength of the game tree, and then we will propagate all these values using the strategy using minimax or alpha beta pruning to decide for the best move. For example, here I have, so here on the screen one example is given. Normally in tic-tac-toe game, if an AI uses the bounded look ahead strategy with a depth limit of 2 moves. What is the meaning of this one? Tic-tac-toe game, we know that the tic-tac-toe game we used to play like using cross symbol or 0 symbol. So for the first player, he may give cross, and the second player, maybe the system can give 0. So this is called as the 2 moves. Okay. So in tic-tac-toe game, if the third player, not the third player, the third turn can be taken by the first player, maybe cross. Again, the computer will play maybe 0. Like this, the play will go on. So in tic-tac-toe game, so if an AI uses the bounded look ahead strategy with a depth limit of 2 moves, then AI will consider only the next 2 moves. I mean, one move is by itself and another move by the opponent. So it does not look ahead to the full game, but stops at the depth 2 and evaluate the board using a heuristic function. So let me tell you what is the meaning of this heuristic function. So as I told, 2 moves, we are fixing the depth up to 2 moves. So one move by the AI agent itself and another move by the user or the opponent party. So at that depth, we can evaluate using the heuristic how much time it will require or how much cost is required to finish the game. So that is why the heuristic values are given in our search space. Okay, these are the key components of the bounded look ahead strategy. The first one is the depth limit, second one is the evaluation function, third one is the minimax algorithm, and fourth one is alpha beta pruning. So what is the meaning of the depth limit? So depth limit, as I discussed now, the maximum number of moves or the maximum number of implies the agent looks ahead, how much distance or how many moves the agent can see, or how much distance it can move and which is visible to us. So that is called as the depth limit. Based on that, we have to fix the depth limit for the game. And evaluation function, it is a heuristic function that estimates the desirability of a game of a given game state. Means starting from, suppose this is my root node and this is my current node. This is the current position, this is the root position, and this is the goal position. Suppose this is the goal position. Now heuristic value will be given for every position except this leaf node, because leaf node heuristic value would be 0. Now for this, if the heuristic value is given as 2, that means maximum 2 distance will be required to reach from this current node to the destination node. So this distance would be heuristic. Okay, but actual distance, if it is the, so actual distance means the distance from the root node to the current node, that is called as the actual distance. But the distance from this current node to the goal node, that is called as the heuristic distance. That is called as heuristic distance. Okay. So now, so this evaluation function, which are called as the heuristic function, which estimates the desirability of the given game state. And minimax algorithm normally we used to use to propagate from the depth cut, from where up to which node we have fixing the depth. From that node onwards we have to propagate to the root node. Now to recognize which move would be the best one, or else we can go for the alpha beta also. So minimax algorithm used to propagate the values from the evaluation function back of the tree. Even in the alpha beta pruning also, it optimizes the minimax search by eliminating or by pruning the branches which do not affect the final decision. These are the advantages of this bounded look ahead strategy, which is used in the game theory. So using this bounded look ahead strategy, we can make fast decision making compared to our exhaustive or informed search or heuristic search. Decision can be made fast and it works well with a good evaluation function. But the problem is it might miss the long-term strategies if a crucial move lies beyond the depth limit. Okay, so that is the main problem. If one important move is there beyond the depth limit, then we may miss the long-term strategy. Then let me discuss about the use of evaluation functions. Evaluation function, as I told, it is a heuristic function which is used to find out the strength of the node or to this goal node. So use of evaluation function in bounded look ahead strategy. So an evaluation function which is used to estimate the quality of the game state when the AI cannot search to the end of the game due to the depth limitation. As I discussed just now, in every iteration or in each move, number of branching factor would be more in case of the game tree. So that is why, as the number of branching factors are more in each step, it would be very difficult to find out it would be very difficult to search the space completely at a stretch. So that is why this bounded look ahead strategy, where we have to keep the depth limit at a fix, and as well as we have to use the evaluation function at a particular depth to maintain or to find out the strength of or the desirability of the position. Okay, so it assigns the numerical scores to a board position, helping the AI decide which moves is the best move. Based upon the heuristic value, we can find out which one would be the best one. Since why this heuristic or the evaluation functions are needed? Since the AI only looks ahead a limited number of moves, like 2 moves in tic-tac-toe, or it may not reach a win or loss state. Instead, it evaluates each possible position using a heuristic function. So that is why the heuristic functions are needed. Then what is the procedure for this evaluation function? So this process, the process of evaluation of a game, is determined by the structural features of the current state. These are the 3 steps are involved for the evaluation of the heuristic function. The first step is to decide which features are of value in a particular game. Means the relevant features which are required to evaluate the features of the game. Second step is to provide each feature with a range of possible values. That values may be the numerical values. And the third step is to devise a set of weights in order to combine all the feature values into a single value. Now, this evaluation function provides numerical assessment of how favorable the game state for the max. Normally, we used to use any numerical values as a evaluation function or heuristic function. The general strategy for max is to play in such a manner that maximizes its winning chances while simultaneously minimizing the chances of the opponent. The node which offers the best path is then chosen to make a move. So for the sake of convenience, let us assume the root node to be the max node. Normally in a two-player game, we used to consider the first player may be the max player and the next player may be the min player. But at certain depth, we have to, using the evaluation function, we can find out the desirability of the position. Now you can see the picture on the screen. It's a picture for the one-player game and two-player game. So consider a one-player and two-player game as shown in below. The score leaf nodes is assumed to be calculated using the evaluation function. Now in the first game tree, this is the first game tree, which is a one-play game, because from this one-play game, because first player is played and these are the leaf nodes. So for the leaf nodes, the evaluation function values are already given. But as the first player is the max player, here the first player is the max player, second player is the min player. So we have to find out the max for the root node. So what is the value here? It is given for this node, it is given as 8. For this node, it is given as 3. And for this node, it is given as -2. So definitely the max node would be, the heuristic value would be 8, because max of all the successor would be 8. So this is the way the value will be propagated from the leaf node to the current to the parent node. But the second game tree, compared to the first one, second game, it is a two-player game. Okay, two-play game, because two people are playing, but the depth limit is 2. But if you consider this first one, the depth limit is 1, because at the first max player is playing here, then min player is playing at this layer. So depth limit, it is fixed up to, or depth limit is equal to 1. We are fixing because up to first depth it is visible to the agent. So that is why it would be very easy to explore or to search the space, as well as we can find out the heuristic value for the max node. In the same way, that for the second diagram, this one, the depth limit is equal to 2. So this is your depth limit 0. Okay, and at this layer depth limit is equal to 1, at this layer depth limit is equal to 2. So here the first player is the max player, next layer is the min player, and third layer is the max player. So for all the leaf node, heuristic values are given to us like -6, 9 and 0. So that is why for min layer the value here it would be min. So minimum between -6, 9 and 0, it is -6. Like this we have to find out all the heuristic value based upon the leaf nodes. Now for this node, it is heuristic value is given 3 and here it is given as 2. So minimum between 3 and 2, it is 2. So for this node, the heuristic value would be 2. Same thing for here. One value, it is not properly visible to me also. It is given as 3 and it is given as -4. So minimum is -4. So out of, now we have calculated, as I told in our procedure of the evaluation function, the evaluation values or the heuristic values will be propagated from the leaf node to the parent node, which we defined for the depth which we defined before. Now as we defined the depth is equal to 2, once it reaches the depth is equal to 2, we have all the heuristic value will be propagated to the root node. Now we have calculated what are the heuristic values at this layer. Now what would be the heuristic value for here, because this node is present in the max layer. So definitely -6 here, 2, and here it is -4. So max between -6, 2 and -4, it would be 2. So like this way, the heuristic value can be calculated very easily if we fix the depth limit at a certain level. Okay, so that such would be efficient and we can get the accurate answers. Okay, decisions can be made easy. So that is the use of this evaluation function as well as the depth in the game playing method. So this is all about for this video. I hope you might have understood both the topics like the bounded look ahead strategy as well as why we are using the evaluation function or the heuristic values. So for the preparation of this video, I have referred the Sarosco's book for artificial intelligence. You can also refer it. In the next class or in my next video lecture, I will explain the minimax algorithm as well as the alpha beta pruning. So till then, thank you, take care, bye bye.
Like, share and subscribe. Hit the bell icon for more updates.